Welcome to the Deep Dive, the show where we take a stack of sources, articles, research, and our own notes, and really extract the most important nuggets of knowledge and insight custom tailored for you.
That's right.
Today, we're diving deep into something so fundamental to our daily lives, you probably don't give it a second thought. Furniture.
It really is. It's the constant, quiet backdrop to our existence, in our homes, our offices, our public spaces.
Yeah.
But what seems simple, like a sturdy chair, a functional table, maybe a spacious cabinet, is actually, well, it's a marvel of clever design, precise engineering, and a surprising amount of regulation.
Okay, let's unpack this then.
Yeah.
Our mission for this deep dive is to explore a truly diverse stack of source materials, peeling back the layers on everything from, say, how furniture is physically put together, to the intricate ways it's designed, the critical safety and quality standards that govern it, and even what its future might look like.
And when we say diverse, we really mean it. Our sources span an incredibly broad spectrum. We're moving from the granular details of wood joints and the hidden chemistry of modern adhesives, right up to macro concepts like biomimicry, that's innovation directly inspired by nature,
Right.
and the sweeping principles of sustainable design. We'll also delve into the vital role of safety protocols in manufacturing and the often overlooked world of costing and professional regulations.
So look out to cover.
A lot. This deep dive promises some surprising facts and plenty of aha moments, all delivered in a way that hopefully won't overwhelm you, but instead leaves you incredibly well informed.
So as you settle in, perhaps on a sofa or at your desk, take a look around. Consider the pieces near you. Have you ever wondered what makes that chair so strong, even after years of use?
Or how an architect meticulously plans every ray of light in a room to make it feel just right.
Exactly. It's fascinating stuff. We're going to give you a shortcut to being well-informed on all of it, revealing the layers of unseen ingenuity in the objects we often take for granted. Let's jump in.
Let's do it.
We begin our deep dive into furniture by looking at where many of its components first come to life. The machine shop.
Right.
Think of a machine shop as a sophisticated machining studio equipped with specialized power-driven equipment designed to drill, bore, grind, or cut materials, ranging from metal and plastic to wood and ceramic.
And these machine shops aren't all the same. They have distinct personalities, you could say, largely dictated by their scale and the type of work they specialize in.
Okay.
At one end, you have job shops. These are highly versatile. They undertake a wide range of specialized jobs of limited quantity, maybe single pieces, maybe up to hundreds of items. They're often called upon for custom work or, say, machinery repair, where speed and adaptable, rugged tools are really critical. A typical job shop, as our sources show, is built for maximum versatility and quick turnaround.
So for unique, bespoke pieces or urgent repairs, that kind of thing.
Precisely. Then there are limited production shops. These sit somewhere in the middle ground.
Okay.
These produce identical parts in quantities maybe from 100 up to several thousand. The machines here are designed for endurance, but they can easily change setups, making them adaptable for those mid-range runs.
More flexible than mass production, maybe?
A bit, yeah. And increasingly, these shops integrate automatic and numerically controlled, or NC, machine tools to boost efficiency.
Right.
And then at the far end of the spectrum, we find mass production shops. This is where parts are manufactured in truly vast numbers.
Huge scale.
Huge. Automatic and numerically controlled machines are utilized to their fullest extent, often performing multiple operations simultaneously. You might even see mechanical arms positioning and repositioning the work, allowing one operator to attend to several machines at once. These shops often have their own numerical control systems, programming computers, even tape-making departments. It highlights their incredible scale and integration.
This raises an important question, though. A machine shop is clearly a true ecosystem of specialized expertise. But who are the skilled individuals making all this happen?
Yeah, that's crucial.
It's not just about the machines, right? It's fundamentally about the people operating them.
Not at all. It's a veritable army of specialists, really, demonstrating the profound human skill that underpins even the most automated processes.
Cuckoo.
For instance, you have precision operators, like the boring machine operator, who precisely drills and reams metal parts to specifications.
Okay.
And the jig boring machine setup operator, their work demands even greater accuracy for critical components like jigs and fixtures, planning the work sequence, laying out reference lines.
Wow, meticulous.
Very. Then there's the engine lathe operator, shaping materials through turning, and the drill press setup operator, handling drilling, countersinking, reaming, all sorts of hole creation. And the gear cutting machine setup operators, this one's interesting, they set up shapers, hobbers, generators for things like splines or gear teeth. Requires real knowledge of gear design and shock mathematics.
So quite specialized knowledge there.
Definitely. You also find specialists in surface refinement, like the tool grinder operator. They set up and run various grinding machines, external, internal, surface for metal workpieces like machine parts or tools, all based on blueprints.
Right.
And the milling machine setup operator, setting up milling machines to mill surfaces, positioning and securing the workpiece carefully.
So we have the shapers and the grinders, ensuring incredible precision. But then there's a whole other category focused on assembly and the broader environment, right?
Indeed. The millwright is crucial here. They install and align heavy machinery and equipment according to plans, using hoists, lift trucks, hand tools, power tools.
The setup crew, basically.
Pretty much.
Yeah.
Reading blueprints, schematic drawings, and for the foundational cutting, you have operators like the planer setup operator for large workpieces, like castings for dies, the shaper operator doing planing or grooving on metal parts, and the metal bandsaw operator handling large sheets, plates, castings.
The rolls.
And then the ultimate generalist, you could say, the master craftsperson, is the all-around machinist.
The expert of experts.
Sort of. This individual is capable of carrying through the construction and repair of all kinds of tools, metal parts, or machines, working directly from blueprints and skillfully using all hand and machine tools. A deep, broad skill set.
That's impressive.
This incredible granularity in roles isn't just about efficiency, though. It's a testament to how modern manufacturing has evolved. It creates both unseen bottlenecks and highly specialized niches for innovation that few outside the industry really grasp.
Right.
It's a sophisticated dance between human skill and automated precision that brings our everyday objects to life with, well, astonishing scale and exactitude.
Okay, so with all these individual components precisely crafted, the real magic begins.
Yeah.
How do you actually bring them together to create something truly strong and lasting? This next part reveals the hidden artistry of wood joinery.
This brings us to the crucial role of joints in woodworking, often just called joinery. Wood joinery is absolutely foundational to quality furniture making. It's both an art and a science, really. It allows cabinet makers to assemble diverse components into an aesthetically pleasing and structurally sound whole.
So form and function together.
Exactly. The quality and longevity of a piece of furniture are directly tied to the craftsmanship of its joints. What's fascinating is how these techniques have evolved over thousands of years.
Thousands, wow.
Oh, yeah. Adapting to increasing design complexity, aesthetic shifts, and the ongoing pursuit of greater durability and efficiency. It's truly a hidden engineering marvel, essential for structural integrity.
Let's unpack a few of the most common and important wood joints then, because each one serves a very specific purpose, right? What are the fundamentals?
Okay, first, the butt joint. This is the simplest. Two pieces are just placed end to end.
Sounds basic.
It is. It's straightforward, but often needs reinforcement like screws or dowels for sufficient strength on its own.
Right.
Then you have the mortise and tenon joint. This is one of the oldest and strongest forms of joinery, used for thousands of years, especially for right-angle connections.
Okay, how does that work?
Think of it like a tongue. That's the tenon fitting snugly into a slot. That's the mortise. It's incredibly strong and stable, often pinned for extra security.
Like a wooden puzzle piece?
Sort of, yeah. Other intricate joints include the dovetail joint, known for its interlocking tails and pins. These provide exceptional strength against pulling forces, often cut with a special dovetail saw.
No, this is complicated.
They can be. You also see dowel joints as an alternative to mortise and tenon, using small cylindrical wooden pins, and things like lapped joints or house joinery, which are sometimes used as exposed joinery in styles like arts and crafts, highlighting the craftsmanship itself.
Interesting. And how do these joints handle the stresses of everyday use? Let's take the example of leg-to-apron joints on a table. They really bear the brunt of everyday forces, don't they?
They do. That's a perfect example of engineering in joinery. Leg-to-apron joints must withstand 3 critical types of stress. Shear from vertical loads, like someone sitting on a table corner.
Right.
Bending from leaning on the tabletop midpoint, and twisting from, say, shoving the table sideways, or even from tabletop expansion and shrinkage if it's fastened too tightly.
So a lot of forces at play.
Definitely. To manage these, cabinet makers often employ haunched tenons. Think of it as adding a clever lock and key mechanism within the joint itself, beyond just the glue.
Okay.
This design features an angled haunch on top and a small shoulder at the bottom. This balances any lost glue surface with a much stronger mortise that resists twisting and bending forces much better.
So it reinforces the connection.
Precisely. Though tiny, these elements are meticulously carved to reinforce the connection against those intense forces of everyday use. The haunch is often cut by hand with a dovetail saw and chisel. The mortise forward is marked, waist chopped out. Keeping the top of the mortise round adds strength too.
And you mentioned a small shoulder at the bottom.
Yes, maybe 18-inch. It helps hide any small inaccuracies in the joint and allows for vertical alignment adjustments.
And what about adding an extra layer of security, almost like an insurance policy for the joint? You mentioned pins earlier.
That's precisely where pins come in. These are small hardwood pins, often of a contrasting wood like rosewood, ebony, or maple, chosen for both strength and aesthetic appeal.
Ah, so they can look good too.
They can. And 2 small pins are actually stronger than 1 large one, distributing the load more effectively.
Interesting.
The holes are drilled after the joint is glued, and pins can be driven from the outside or inside. Crucially, pinholes are slightly offset.
Why offset?
To avoid splitting the leg wood along the grain and to ensure optimal engagement, pulling the joint tighter as the pin is driven in.
Clever. And the glue.
For the glue itself, a thin, even layer of yellow glue is best for snugly fitting joints. And a slight chamfer, like a tiny bevel around the mortise, helps contain any glue squeeze out, ensuring a clean finish.
Right.
The joint should ideally slip together under light clamping pressure. Hide glue is also a favored choice.
Why hide glue?
Well, it has a long open time, meaning you have more time to assemble complex pieces before it sets. Plus, it's reversible with heat and moisture, which is great for future repairs.
Oh, that's useful. And for narrow rails, like under drawers.
Right. For those, doubling the tenons, making 2 smaller ones side by side instead of 1 large one, really maximizes strength and stability in that smaller space.
It's clear that selecting the right joint is absolutely critical for any woodworking project. It dictates both the final look and how long the piece will last.
Undoubtedly. The choice depends entirely on the specific needs of the furniture piece, balancing aesthetics, structural integrity, and, its intended use. These techniques, some ancient and some more modern, are really the hidden engineering that provide incredible strength and durability to the furniture we use every day.
So with all this intricate joinery, it's tempting to think that's the whole story. But modern furniture relies heavily on another unsung hero, adhesives.
That's right. While traditional joints are foundational.
Yeah, it's fascinating to think about how glues complement and, in some cases, even enable entirely new designs and construction methods.
Indeed. We're primarily talking about synthetic glues here, and their role is constantly expanding. They're essential for bonding diverse materials, not just wood to wood, and solving specific design challenges that traditional methods might not easily address. It's a whole world of applied chemistry, really, allowing for stronger, faster, and more versatile assembly.
Let's walk through some of these then, detailing their properties, ideal applications, even some important safety considerations. Let's start with a very versatile one, epoxy.
Okay, epoxy. It's an extremely tough and durable synthetic roofing. It typically comes as a 2-part system that you mix together before use.
Right, the resin and the hardener.
Exactly. When combined, it creates a powerful bond that's incredibly versatile. It's great for joining a wide variety of dissimilar materials, think metal or stone, to wood.
Oh, okay.
Even in harsh conditions where moisture or temperature extremes are a factor. However, and this is crucial, both the resin and the hardener are irritants, and their vapors can be toxic. So proper ventilation and protective gear like gloves and eye protection are absolutely essential when working with epoxy.
That's a crucial safety point. Okay, what about the speed demon of adhesives? Instant glue, chemically known as ethyl cyanoacrylate.
Super glue, basically. Yeah. Yes, as the name suggests, it's incredibly fast bonding. While it originally worked best on smaller, non-porous surfaces, you can now find gel versions that work better on more porous materials like wood.
Okay.
That significantly expands its applications. Accelerators can be used to speed up curing even more if needed.
Right.
The bond is instant, typically colorless and transparent, and remarkably strong in tension. And it leaves virtually no visible residue, which is great for aesthetics. Perfect for quick, precise bonds where you need parts to hold immediately.
What about something that needs to fill gaps, maybe? Or for those traditional wood joints we talked about?
That would likely be polyurethane glue. A key characteristic is that it expands as it cures.
Expands.
Yeah, it foams up a bit, which can be a bit messy sometimes. You have to manage the squeeze out.
Okay.
But that expansion helps it fill voids and holds materials very well. This makes it excellent for traditional wood joints like mortise and tenons, where you might have small gaps or slight imperfections.
Got it. And for something like glass furniture where you need a crystal clear bond without any haze or visible residue.
That's where UV glue comes in. It utilizes ultraviolet light for curing.
So you need a special light.
Yes, you need a UV light source. The glue remains liquid until exposed to the UV light, then it cures very quickly, resulting in a permanent and remarkably clear bond.
And one of the materials has to be clear.
Exactly. For this to work, at least one of the materials being bonded must be transparent to allow the UV rays to penetrate and cure the glue underneath.
Makes sense.
This makes it especially useful for bonding glass in furniture, say glass tabletops to bases, as it doesn't leave any unwanted fog or residue, ensuring a pristine appearance.
Wow.
The sheer variety and sophisticated chemistry of these adhesives truly highlight how material science continuously innovates. It's not just glue, it's really a foundational element of modern furniture design and construction.
While wood is definitely a cornerstone of furniture making, many pieces integrate other materials. Let's introduce stone as a furniture material now, because it brings a whole different set of considerations to the table, literally.
Yes, stone adds a completely different dimension. Natural stone is highly regarded as a premier building material, and that extends to furniture.
Why is it so valued?
Well, it reflects unique character, stability, and a certain grandeur. Its variations in color, pattern, and texture are visually interesting and impossible to replicate. Each piece is unique. Plus, it's eco-friendly, drawing directly from the Earth's natural beauty. The sheer diversity of natural stone products encourages limitless design potential, and its often neutral colors pair excellently with a wide range of chair and furniture styles.
So truly one-of-a-kind pieces.
Absolutely. Each piece has a unique texture and unrepeatable beauty. As one source puts it, one will never be the same as another.
And the value.
The value of natural stone extends beyond just monetary measure. It involves longevity, ease of maintenance, permanence, stability, qualities that often far exceed the initial investment. Yeah. And interestingly, it's become more affordable now.
Oh, how so?
Due to advancing quarrying and processing technology, they can make thinner, faster, and more consistent cuts at less cost now. Installation is also easier and more secure thanks to new anchoring technologies.
Yeah.
Natural stone is generally simple to care for, it improves with age, and it can last a lifetime.
So what are some common natural stones used in furniture, and what are their unique properties or maybe trade-offs?
Okay, let's look at a few. Onyx is highly decorative. It has this crystalline structure, dramatic color, and remarkable translucency. Especially when backlit, it can truly glow.
Sounds beautiful.
It is. However, it's quite fragile and soft. It almost always needs a sturdy backing, usually a fiberglass mesh to give it strength. And it's prone to scratching or chipping.
So maybe not for heavy use.
Exactly. This makes it a poor choice for, say, kitchen countertops or high-traffic flooring. And it's very susceptible to acid etching, erosion, and water damage. Needs special cleaners and sealants.
So a balance between beauty and practicality there.
Definitely. This inherent tension between onyx's stunning beauty and its practical fragility perfectly illustrates a core dilemma in furniture design, balancing breathtaking aesthetics with the everyday realities of durability and maintenance.
What else?
Limestone, which is mainly calcium carbonate, is attractive and heat-resistant, making it suitable for certain kitchen countertops, but it requires significant upkeep as it scratches easily.
Okay.
Being porous and usually light-colored, it's easily stained by acidic liquids like lemon juice or black tea.
Right. You need to be careful with spills.
Very. Travertine is actually a form of limestone, commonly found in white, tan, or cream, but it can range to gray or even reddish coral. It's available in filled and unfilled options, each offering a distinct aesthetic. Filled is smoother, unfilled has natural pits. And then there's marble, widely recognized for its elegance, refinement, and ability to add cachet to any decor.
Classic choice.
Very classic. It's a metamorphic rock with distinctive veins of calcite crystal formed from limestone, and it's found in many colors depending on its mineral impurities.
Beyond natural stone, there's also a growing category of man-made stones. How do these compare, and what advantages do they offer designers?
Good question. Engineered quartz stone, also known as reconstituted or recomposed stone, is a big one. It's manufactured from quartz aggregate chips, a resin binder, usually polyester, pigments, and additives.
So it's predictable.
Very. It offers a huge range of consistent colors, patterns, and textures. You can even combine it with glass or reflective materials for sparkling finishes. It's popular in high-end applications because it combines granite's durability with quartz's non-porous nature.
Non-porous is good for kitchens, bathrooms.
Absolutely. The key benefits are its uniformity, which minimizes dry lay pre-selection during installation. You know what you're getting: better scratch resistance than many natural stones, and a consistent pattern, texture, and color that reliably resembles natural stone without the inherent variability.
Makes sense for consistency. What about terrazzo?
Terrazzo is a composite material, traditionally used for floors and walls, but now increasingly seen in furniture and accessories. It consists of chips, marble, quartz, granite, glass poured with a cementitious or polymeric binder.
Right, you see those distinctive chips.
Exactly. Metal strips often divide sections or create patterns. After curing, it's ground and polished smooth, revealing that unique speckled surface. It's having a real design moment right now.
I've noticed. And solid surface.
Solid surface material is another type, often made from modified acrylic and polyester resins, marble dust, and pigments. Its big advantages are remarkable versatility, non-porosity, ease of maintenance, and crucially, it can create a continuous surface without visible joints. Yes, allowing for seamless integration and sleek modern designs, like integrated sinks and countertops.
What kind of specialized equipment is needed to transform these raw stone materials into furniture components?
Yeah.
It can't be easy.
No, it requires specific tools. For cutting stone, a tile wet saw is absolutely essential.
Wet saw.
Yes. Unlike cutting wood, this saw uses water to cool the blade and wet the dust. This is critical for keeping the air clean and preventing harmful silica dust from becoming airborne, which is a major health hazard.
Right, safety first.
Always. It allows for indoor work if the area is protected, though eye protection is still paramount. For breaking stone, especially for rough shaping or splitting thicker slabs, there are specialized tools like carbide-tipped stone busters.
Chum busters.
Yeah, they're essentially hammer versions of a tool called a hand tracer. They feature a heavy-duty carbide blade and a hardened striking face for controlled precision breaking.
Okay. And when it comes to installing stone into furniture, beyond just placing it, what are the key considerations for durability and safety? Stone is heavy.
It is, and potentially brittle. Several factors are crucial. Sealers may be applied depending on the stone type, location, and usage. If it's for food prep surfaces, sealers must be non-toxic.
Makes sense.
Base design is critical. It requires adequate support. Often 3/4-inch marine plywood is recommended to prevent accidents and fracturing under the stone's weight.
Okay.
For unsupported spans and overhangs, the size depends critically on stone thickness and type. Generally, projections beyond 6 inches aren't recommended for stone 3/4 inch or less thick.
Right.
And fragile stones like onyx might not be suitable for large overhangs at all. Thicker stone allows greater spans, and overhangs can be increased with structural support, like adding that plywood layer underneath.
And the edges.
All exposed edges must be carefully gauged and finished. You don't want sharp edges. Dimensions for specific edge treatments like bevels, quirk miters, or the radius of rounded edges should be clearly specified by the designer. For laminated aprons where you build up the edge thickness and double thicknesses, all jointed edges and horizontal surfaces must be sanded or ground for 100% contact. This prevents future delamination or separation.
Okay.
And finally, a key point. Oil-based putty and sealants are generally prohibited from direct contact with stone.
Why is that?
They can actually seep into the pores of the stone and cause permanent staining or discoloration. You need to use stone-specific, non-staining adhesives and putties.
Good to know. How about everyday care and maintenance for stone furniture? What typically causes damage, and how can we prevent it?
Common causes of damage include permanent stains, especially from acids. Think foods like tomato, mustard, fruit juices, wines.
Oh.
Yeah, this is particularly problematic for stones like Carrara marble and limestone. Red wine vinegar, for instance, can etch strongly and even leave a pinkish discoloration.
Not good.
No. Chips and cracks often result from heavy impacts dropping something heavy on it. And abrasions or scratches can come from grit being dragged across the surface.
So how to care for it?
Always wipe spills immediately, especially acidic ones. For everyday cleaning, a mild detergent and water is usually sufficient. Just gentle cleaning.
Okay.
Sealing the stone is highly recommended for stain prevention. And for outdoor pieces exposed to the elements, sealing is pretty much mandatory, maybe yearly. For indoors, follow manufacturer recommendations.
And for tougher stains?
For deep cleaning of difficult stains like ink, wine, grease, or oil. White spirit, mineral spirits, can be effective, but always test it on a non-visible area first to make sure it doesn't damage the stone finish.
Good advice.
And you might need to reseal the area after deep cleaning, as the solvent can remove the existing sealer.
Shifting gears now, let's look at the broader context of interior design beyond just the individual furniture pieces. How are these spaces meticulously planned, rigorously regulated, and ultimately made safe and functional for us, often in ways we don't even perceive?
This is where comprehensive frameworks come in, like the National Interior Design Code of the Philippines, or ID Code, mentioned in our sources. It serves as a referral code for the National Building Code. Its aim is the functional, orderly, and aesthetic arrangement of interiors.
So setting standards.
Exactly. Its purpose is to set minimum standards compatible with international norms and to continuously update for advancements in science and technology. It's basically a blueprint for creating spaces that serve human needs in every dimension: safety, function, comfort.
So what does this all mean for someone wanting to build or renovate a space? How does this code translate into practical requirements?
Well, a crucial part of the regulatory framework is the ancillary permit for interior design construction.
Ancillary permit.
Yes. This permit must be duly signed and sealed by the corresponding professional, meaning the licensed interior designer.
Oh.
It's submitted along with the main building permit application, and without it, the building permit is actually rendered null and void.
So it's essential.
It is. The application itself requires an accomplished form, comprehensive plans, specifications, and other contract documents, all signed and sealed by the interior designer.
And the plans have to be detailed.
Very. The floor plan, in particular, must be highly detailed. It needs to show all floors, including basements, all rooms with their intended use, finishes, overall dimensions.
Right.
Precise locations of structural elements like columns and walls, openings, doors, windows with schedules, if applicable, and all fire safety components like fire-rated assemblies and area separations.
Wow. And what if changes are needed during construction?
That's tightly controlled. Any deviation or change from the original approved plans must be authorized in writing and countersigned by the interior designer who prepared them.
Accountability.
Exactly. And these changes must be meticulously recorded in the official building construction logbook. This ensures adherence to safety and design standards throughout the project.
Beyond the legal and structural aspects, how do interior spaces directly impact our comfort, health, and sensory experience? It seems the code goes far beyond just basic construction.
Absolutely. The ID code delves into how interior spaces directly impact our comfort, health, and overall sensory experience. It moves beyond mere aesthetics to fundamentally shape our well-being.
How so?
For instance, it sets fundamental requirements for natural light and ventilation. It mandates adequate light and ventilation in rooms. Buildings generally must face a street or an approved private street, and no alteration can reduce room size or window area below the cone minimums.
Are there minimum sizes?
Yes. There are minimum room sizes specified for human habitations, like bedrooms, kitchens, and bath toilet rooms. There are also minimum airspace requirements per person for various settings like schoolrooms, workshops, offices, and habitable rooms, ensuring enough volume for healthy air quality.
And windows.
Window openings must provide a minimum clear ventilating area, usually not less than 10% of the floor area of the room, opening directly to an open court, yard, street, or similar open space. This ensures sufficient air circulation and natural light.
And what about clever design strategies for natural cooling and ventilation, especially in warmer climates like the Philippines, where this code originates?
The code encourages arranging rooms to take full advantage of air movements and cross-ventilation. This can be through traditional elements like ventanillas, those are openings under windowsills.
I see those.
Or transoms over windows and door heads, fixed louvers, or even perforated walls or partitions to allow airflow.
Smart passive design.
Exactly. And if natural ventilation isn't sufficient, artificial ventilation is required, especially for rooms housing industrial or heating equipment. Minimum air changes per hour vary by room type, maybe 3 changes per hour for offices, but up to 10 for kitchens and boiler rooms, reflecting the need for removing heat and fumes.
Okay.
The code also specifies comprehensive requirements for interior surfaces, finishing materials, and construction.
What kind of material?
Well, for interior walls and partitions, it lists examples ranging from common fiber cement board and solid wood to more advanced solutions like cement stucco on metal furring or precast glass fiber reinforced concrete, or even structural glass blocks. It allows for balancing structure, aesthetics, and cost.
Right.
Ceilings might use acoustical thermal insulation or fire-rated ceiling board on metal suspensions, which is crucial for both comfort, sound, and heat, and safety, fire. Moldings and trims offer further design flexibility with materials like solid wood, fiber boards, extruded aluminum, or precast plaster. Flooring finishes cover a huge range. Wood planks, laminated wood, vinyl or rubber tiles, sometimes treated with antibacterial agents for hygienic areas like hospitals.
Good point.
Durable options like ceramic, marble, granite, and various types of carpets. Windows and doors offer choices like frameless glass, aluminum, or steel tubular sections with various glass types, plain, wired, tempered, and solid or plywood door panels.
And crucially, the quality and safety of these finishes.
Absolutely critical. All surface finishing materials like fabrics, wall covers, and paints must conform to national standards like DTI and Fire Bureau in the Philippines context for things like inflammability, fire resistivity, flame spread, and toxicity of gases produced when burning.
Flame spread.
Yes, materials intended to be flame spread proofed need a specific low rating, like 50 or less on a standard tunnel test. And things like gypsum ceiling board or wall board should ideally have a 1-hour fire rating, meaning they resist fire penetration for that long.
That's vital for safety.
Yeah.
And beyond the materials, what about electrical safety and the use of glass in spaces?
All electrical wirings and lighting fixtures must conform to the relevant engineering code and national standards, ensuring safety and preventing electrical hazards.
Okay.
For glass and glazing, the code is very rigorous. It defines glass properties and lists basic types like window sheet glass, float glass, which is very common now, and plate glass. Variations include pattern glass, wire glass with embedded wire mesh for safety, cathedral or art glass, obscure glass, like frosted, and high-performance options like heat-absorbing tinted glass, reflected coated glass for solar control, and security glass, which uses plastic film between layers for bullet or burglar resistance, often quite thick.
And impact safety, like indoors.
Yes. Impact requirements are stringent. It mandates shatter-resistant materials like wire-reinforced glass, fully tempered glass, or laminated safety glass of specific minimum thicknesses for high-impact areas. Think frameless glass doors, glass in regular doors, or large fixed panels near walkways.
Makes sense.
There are exceptions for small panes or panes high off the floor. It also specifies minimum thickness and edge requirements for louvered windows. The goal is to ensure that beauty never compromises safety, especially with large expanses of glass.
Okay, the code also gets into FF&E, furniture, furnishings, and equipment.
It does. It provides detailed guidance on FF&E selection and specification. The interior designer is responsible for coordinating colors, fabrics, and finishes with the structural interior design materials.
So that all works together.
Exactly. Ensuring style, function, and configuration meet the user's needs. This includes items like workstations, seating, files, tables, beds, wardrobes, draperies, accessories, even marker boards or presentation screens. Secondary window treatments like shears are also covered.
What criteria guide these selections?
Key criteria include function, ergonomics, maintenance, durability, sustainability, comfort, and, of course, cost. Consideration of any existing furnishings that need to be integrated is also important.
And planning the layout.
Furniture footprint plans are critical. These meticulously show the appropriate size and type of furnishings and, very importantly, the critical clearances needed for circulation and use.
So people can actually move around.
Precisely. These plans serve as the basis for integrated project design. The interior designer is responsible for equipment space allocation and coordination with building systems like lighting, power outlets, mechanical vents, even window placement.
So it's all connected.
It has to be included throughout the design process, from concept to final submission, to coordinate everything properly. This means every piece of furniture isn't just dropped into a space. It's intricately woven into the overall design fabric from the beginning.
And the code even gets into specific furniture dimensions. I saw that in the notes. It's truly comprehensive.
It is. It gets surprisingly specific. For example, rectangular conference or dining tables have specific length, width, and height ranges provided.
Really?
Yes. And it even notes that a height of 730 millimeter, about 28.7 inches, is explicitly recommended for the average Filipino stature, with a complementing chair seat height of 430 millimeters, about 17 inches.
Wow, that's tailored.
It demonstrates how even a seemingly simple table is engineered for optimal human interaction and comfort within a specific context. Similar detailed dimension ranges are provided for other tables, typing desks, general purpose, secretarial, clerical, junior executive, senior executive tables.
Okay.
Side and end tables are noted as variable, but their max height often follows the armrest level of adjacent seating, though commonly a bit lower. Width is flexible. Depth often follows the adjacent chair. Specific ranges are given for rectangular, square, and circular side tables.
And coffee table.
And low tables, yeah. They should be proportionate to other furniture. Height usually follows the seat height of surrounding sofas or chairs, maybe slightly higher. Again, specific dimension ranges are provided for rectangular, square, and circular types.
What about sleeping spaces?
The code also outlines general dimension ranges for beds and sleeping spaces, using letter codes AF in the source example, and provides standard mattress sizes in both English and metric units, covering everything from bunk and dormitory hospital beds to twin, double, queen, and king sizes. Ensures adequate space planning.
That's astonishingly detailed. What about safety in terms of how spaces are used, preventing common accidents?
Yes, the code addresses safety and security related to common hazards in detail, often drawing from tables or guidelines within the code appendices.
Like what kind of hazards?
For falls, it advises against slippery flooring materials and suggests avoiding small, loose rugs or using anti-slip underlays if necessary. For bathrooms, it recommends grab bars, non-skid surfaces on floors and in tub showers, and outward opening doors for easier access or rescue if someone falls inside.
Good practical advice.
For steps, the guidance is to avoid level changes or single steps if possible. If unavoidable, they must be clearly marked using contrasting colors, materials, or lighting, and ideally have a handrail or safety light.
Right, trip hazards.
Exactly. Stairways require moderate slopes. Long runs should be broken with landings. Handrails are needed on both sides, and sometimes a center rail for wider stairs. Good lighting is essential. Avoid slippery materials on treads. Use non-skid treads or nosings. Wingers, triangular steps, should generally be avoided, and the beginning of a stair needs to be clearly marked.
What about windows?
For windows in high locations, especially where children might be present, the code suggests considering safety bars, rails, or using window types that restrict how far they can open.
Okay.
Non-skid surfaces are also specifically mentioned again for tubs and shower bottoms. And for pools, controlling access, like with fencing and gates, and considering railings and anti-skid flooring around the pool deck are key safety considerations.
So what does this all mean? Taking it all together, modern interior design is clearly not just about isolated objects or aesthetics.
Not at all.
It's about creating responsive, inclusive, and future-proof environments. It fundamentally considers human well-being and planetary health in every aspect of a space.
Precisely. From the environmental impact of a building to the smallest detail of a sign's color contrast for accessibility, modern design integrates a profound ethical responsibility. It's about designing environments that are truly fit for human habitation in the fullest sense. And that requires incredible foresight and a keen eye for detail, not just aesthetics. This comprehensive approach is what truly sets apart thoughtful, responsible design.
Okay, so building on that, our sources reveal that furniture and interior design are rapidly evolving to address global challenges. Two major philosophies shaping this future seem to be sustainable design and universal design.
Yes, these are huge drivers.
How do these philosophies transform the way we think about our living spaces, pushing beyond traditional aesthetics?
Let's begin with sustainable interior design, which is often synonymous with green building principles. This approach is about creating high-performance buildings and communities.
High performance how?
Meaning they are not only less expensive to build and operate in the long run, but are also healthier and more comfortable to occupy. This ultimately boosts productivity and well-being for the people inside.
Okay.
It's about achieving multiple benefits from single expenditures through a really integrated design process that considers every aspect of the physical environment right from the start.
What are the core principles?
Core principles include using simpler, appropriate technology, incorporating passive, energy-conserving strategies like good orientation and shading, using renewable and indigenous materials where possible,
Right.
optimizing space to minimize resource consumption, maximizing the reuse and recycling of construction debris, designing for future expansion with materials that can be easily repurposed.
Thinking long term.
Exactly. Making it easy for occupants to recycle waste, applying natural conditioning techniques like ventilation, avoiding overdependence on mechanical systems, and really analyzing the local climate's assets and liabilities. It's about working with nature and resources, not against them.
So it's a holistic approach.
Yeah.
And how does this translate into practical integration strategies within the actual design process?
Two major strategies highlighted in our sources are daylighting and energy analysis. Here, designers work meticulously to integrate natural light with the architectural form, the type and placement of glazing, shading devices, electric lighting, and controls.
The goal.
The goal is to improve visual performance for occupants, save significant energy on lighting, and create healthier, more inviting spaces. Computer simulations and physical models are often used for this.
Okay. And the other strategy?
Green material selection. This involves carefully choosing environmentally preferable and cost-effective materials. It's about greenlining existing specifications, essentially, systematically reviewing and revising standard material choices to ensure the project goals align with sustainability.
So digging deeper into the materials themselves.
Really digging into the supply chain, the embodied energy, the toxicity, the end-of-life potential. This also intrinsically ties back into the sensory experience of a space that we touched on earlier.
How so?
Beyond just visual elements like scale, rhythm, proportion, balance, and using muted colors that blend with the natural context, sustainable design considers sound, minimizing unnatural noise, locating noisy service functions away from public areas, orienting openings towards natural sounds like rustling leaves or water.
Interesting.
For touch, it might involve varying walking surfaces or using contrasting natural textures. Even smell is considered, allowing natural fragrances from plants or materials, directing utility exhausts away from intake vents.
And taste.
And yes, even taste, perhaps by providing opportunities to sample local produce in a cafeteria or community space, connecting people to the local environment. It's about engaging all the senses in a way that supports well-being and connection to place.
That's a truly comprehensive approach, influencing every sensory detail. Now let's turn to universal design. This seems to tackle accessibility head-on, right?
Absolutely. Universal design is a philosophy focused on designing products and environments to be usable by all people to the greatest extent possible, without the need for adaptation or specialized design. It benefits everyone, not just people with disabilities.
What are its guiding principles?
It's guided by 7 key principles developed at North Carolina State University. Let's quickly go through them.
Okay.
1. Equitable use. The design is useful and marketable to people with diverse abilities. Provide the same means of use for all, avoid segregating users, ensure equal privacy, security, safety, and make it appealing. Think power doors that everyone can use.
Yeah.
2. Flexibility in use. Accommodates a wide range of individual preferences and abilities, like scissors designed for both left and right-handed users, or an adjustable height desk. 3. Simple and intuitive use. Easy to understand regardless of user experience, knowledge, language, or concentration level. Eliminate unnecessary complexity, be consistent with expectations, accommodate varying literacy levels, arrange info by importance, provide effective prompting. Think clear icons, straightforward instructions.
Makes sense.
4. Perceptible information. Communicates necessary information effectively, regardless of ambient conditions or user sensory abilities. Use redundancy like a visual alarm, also having an audible component. Maximize legibility, differentiate elements clearly, ensure compatibility with assistive sensory devices.
Okay.
5. Tolerance for error. Minimizes hazards and adverse consequences of accidental or unintended actions. Arrange elements to minimize errors, provide warnings, implement fail-safe features, making it hard to use something the wrong way, like the undo function on a computer or a plug that only fits one way.
Good examples.
6. Low physical effort. The design can be used efficiently, comfortably, and with minimum fatigue. Allow neutral body positions, minimize repetitive actions. The classic example is lever door handles instead of round knobs that require twisting.
Much easier for many people.
Way easier.
Yep.
And 7. Size and space for approach and use. Appropriate size and space is provided for approach, reach, manipulation, and use, regardless of a user's body size, posture, or mobility. Ensure clear lines of sight, comfortable reach to components, adequate space for assistive devices like wheelchairs or walkers.
So it really impacts every detail, even down to the signs and graphics in a space.
Precisely. A crucial application of universal design is in graphics and signs, especially for people with physical challenges or visual impairments. This includes things like the international symbol of access, the familiar wheelchair symbol, which must be placed consistently where accessibility is provided. And yes, the text on signboards must be dimensioned for readability by people with less than normal vision acuity. For example, one rule mentioned is that vertical components of letters should be 15 of the overall letter height for certain viewing distances.
That's specific.
It has to be. And color contrast rules are vital for those with partial sight or color deficits. It's not just about individual colors, but their contrast. Lateness contrast is actually the most important attribute for effective visual contrast.
So light text on a dark background might not always be best.
Not necessarily if it reduces the overall visual effectiveness or causes glare for some users. It's about ensuring the information is clearly perceptible to as many people as possible.
So what does this all mean for the future of our spaces? These twin pillars, sustainable and universal design, these seem to be pushing modern interior design way beyond just aesthetics.
Absolutely. It means modern design isn't just about isolated objects anymore. It's about creating responsive, inclusive, and future-proof environments. They fundamentally consider human well-being and planetary health in every single aspect of a space. It's truly a profound shift.
From the environmental impact of a building's footprint to the smallest detail of a sign's color contrast.
Modern design integrates a deep ethical responsibility. It's about creating spaces that are genuinely beneficial for all people and for the planet, moving beyond mere aesthetics to truly holistic and responsible design. These are powerful concepts driving the future of how we live and interact with our built world.
Okay, we've explored what furniture is, how it's made, its regulatory context, even its future direction. But how do manufacturers actually determine the price tag on that beautifully crafted chair or table?
Ah, the money question.
Let's take a deep dive into the complex world of furniture costing, where hidden numbers play a huge role.
Right. It's definitely not simple. To understand costing, especially in the wood products and furniture industry, we first need to define some key cost terminology.
Okay.
Manufacturing or product costs. Pretty straightforward. These are all costs directly related to producing the goods.
Makes sense.
This includes direct materials. These are the raw materials easily traceable to the product itself, the wood, the fabric, the hardware, the foam. Then there's manufacturing overhead, also called factory overhead, factory burden, or just overhead. This covers all the other production costs besides direct material and direct labor costs.
And that's the tricky part.
That's usually the trickiest part, yeah, because it includes things like factory rent, utilities, depreciation on machinery, salaries of supervisors, maintenance, costs that aren't easily tied to one specific chair.
So what falls under that overhead umbrella, and how do companies even begin to figure out how to allocate it? It seems complicated.
It is. Historically, many firms use traditional cost systems, sometimes called the direct method. Our sources even note it being humorously referred to in certain contexts as the Pacquiao method.
Why that?
Presumably a nod to its straightforward, direct approach, perhaps seen as less nuanced. These systems were popular because they were simple. They often used just a single cost driver like direct labor hours to allocate all that overhead we just talked about.
So relatively easy to calculate, maybe, but perhaps not very precise, if labor isn't the main cost anymore.
Exactly, and that's the big but. With the reduction of direct labor due to increasing automation and the proliferation of complex, expensive machinery, these traditional methods started to hide critical cost issues.
How so?
Because direct labor hours were no longer the main driver of costs in many modern factories.
Right.
Allocating massive overhead based just on dwindling labor hours meant the costs weren't being assigned accurately to the products that actually consumed those overhead resources, like machine time, energy, setup complexity.
So products could be mispriced.
Terribly. This could lead to costly consequences, selling complex products too cheaply or simple products too expensively, making bad decisions about which products to focus on. This led to the evolution of activity-based costing, or ABC.
Okay, ABC. How does that work differently?
ABC is a far more granular and potentially accurate method. It works by first identifying the specific activities performed within the factor, things like machine setups, material handling, quality inspections, product design changes.
Right? Then it assigns the overhead costs to those activities. Finally, it allocates those activity costs to the products based on how much each product consumes those activities.
So it tracks the real drivers of cost.
That's the idea.
Yeah.
It provides much better insight into where overhead costs are actually coming from and which products are driving them. This leads to benefits like improved profitability analysis by monitoring total life cycle cost, better budgeting, encouraging continuous improvement by highlighting costly activities, linking cost to corporate strategy, helping eliminate waste, and improving decisions on things like make or buy, estimating, and pricing.
That sounds incredibly beneficial for precision.
Hmm.
But are there any complexities or downsides to implementing ABC? It sounds like a lot more work.
There can be. Implementing an ABC system can be very expensive initially, and it requires special expertise. You need people who truly understand the system and can manage it effectively.
A significant challenge, often called its Achilles heel, is the sheer difficulty in gathering and maintaining consistently accurate activity information. It demands robust data collection systems and processes, which can be costly and time-consuming.
So how does ABC account for costs, if not just through direct labor? What specific activities does it track using these cost drivers?
Right. Cost drivers are key to ABC. They are defined as the cause and effect relationship between the cost objects, like that specific chair model, and the activities needed to make them.
Okay.
They essentially estimate how costs behave based on specific actions, helping to identify critical cost factors more accurately than just labor hours. And these drivers occur at different levels within the factory.
Different levels.
Yes.
Yeah.
Unit-level cost drivers.
Uh-huh.
These affect only one production unit. The classic examples are direct materials and direct labor for that single chair. Pretty straightforward. Then, batch-level cost drivers. These affect the entire production lot or batch. Think about the cost of setting up a machine specifically for that batch of chairs, or the cost of moving that entire batch from the cutting station to the assembly station. These costs happen once per batch, regardless of how many chairs are in it.
Got it.
Next, product-level cost drivers. These come from activities supporting the product line itself, but not individual units or batches. Examples include specific product engineering costs for designing that new furniture line, or the costs of scheduling production orders unique to that product.
Right, supporting the product overall.
Exactly. And finally, factory-level cost drivers, or facility-level. These support the entire facility's operation and aren't easily traced to specific products, batches, or units. Think broader costs like factory rent, utilities, insurance, general building maintenance, the plant manager's salary, costs that benefit all products made there. ABC tries to allocate even these more rationally than traditional methods. So much more granular, really pinpointing where costs are incurred. Let's make this concrete with examples of what actual components go into the cost when manufacturing a piece of furniture, using maybe this ABC thinking. What are the main buckets?
Okay, let's imagine costing a wooden chair. You'd begin with materials. That's tracking the quantity and precise cost of everything physical that goes into it. The specific type and grade of wood, the wood glue, nails, screws, paint or stain, maybe wood putty, cushion materials if it's upholstered, any waxes or finishes. That's your direct material cost, a unit level cost.
Okay.
Then there's labor. This includes the direct labor, the time spent by carpenters, carvers, upholstery installers, sanders, packagers, finishers applying wax or final touches. These can be calculated as fixed costs per piece or, more likely, based on hourly wages multiplied by the time spent, another unit level cost.
Right. Then comes the operations overhead. This is when ABC gets applied. It includes charges for machine use, often calculated hourly based on machine cost, maintenance, energy, potential activity driver, quality control staff wages, may be allocated based on inspection time per batch or product line, taxes like VAT, and other general overhead allocations, which are now more accurately distributed using those ABC drivers we discussed, maybe number of setups for batch costs, complexity of design for product costs, or even just square footage for factory-level costs like rent.
Got it. And logistics?
Finally, logistics. This covers the entire supply chain cost, the delivery of raw materials to the factory, and then the cost of packaging and shipping the finished product to the customer or retailer. These might be allocated based on weight, volume, or distance.
Wow, it's a lot.
Yeah.
You mentioned something interesting earlier. Why is knowing this production flow so crucial for a designer, beyond just creating something beautiful?
Because this understanding allows a designer to anticipate and potentially mitigate price variations that might arise due to internal factory changes or external market shifts.
So.
If you, as a designer, create something that, while aesthetically stunning, is incredibly complex or inefficient to manufacture, requiring lots of unique machine setups, batch costs, intricate hand labor, unit cost, or specialized finishing processes, activity cost, it's inevitably going to cost more to produce.
Right.
Understanding the manufacturing process and its cost drivers helps you design smarter from a cost perspective, too. It's not just about aesthetics. It's about considering manufacturability, material efficiency, ease of assembly, the entire economic life cycle of a product.
Designing for cost, essentially.
Partly, yes. Or at least designing with an awareness of the cost implications. It's also important here to quickly note the practical difference between nominal lumber sizes and actual lumber sizes that affects material costing.
Ah, yes, the 2x4 thing.
Exactly. Nominal refers to the general name, like a 2x4, which in physical reality, after milling and drying, actually measures maybe 112 inches by 312 inches. The actual size is the measured dimension, often 14-inch to 34-inch less than the nominal size.
Why does that matter for costing?
Because you pay based on the nominal size. Board feet calculation often uses nominal, but you design and build based on the actual size. Misunderstanding this can lead to errors in material ordering, waste calculation, and ultimately inaccurate costing, potentially structural issues, if the design relied on the nominal size. It's a key detail for accurate cost estimation and precise design.
The price tag on a piece of furniture, then, is clearly a really complex calculation. It's influenced by these hidden overhead costs, changing labor dynamics, sophisticated accounting methods like ABC.
Absolutely. This understanding offers a completely new perspective on the true value and economics of craftsmanship, showing just how much meticulous thought, innovation, calculation, and hidden cost goes into that final number we see on the price tag.
Wow, what an incredible journey we've taken today. From, the microscopic chemistry of glues that bind our everyday objects to the macro-level planning of building codes that shape our entire living environments.
It really highlights how furniture and the spaces it inhabits are not just collections of parts. They're truly a culmination of sophisticated design principles, cutting-edge material science, incredible engineering precision, meticulous safety regulations,
Right.
and even deep inspiration from nature like biomimicry and advanced computational design. It's a profound testament to human ingenuity across so many diverse fields.
Each element, from something as seemingly simple as a butt joint providing foundational structural integrity to a carefully chosen finish that meets stringent fire safety standards, or a complex algorithm used to design foldable furniture that optimizes space. Each plays a critical, often unseen role.
Yeah.
A role in bringing these essential objects to life and making them functional, safe, and beautiful for our daily lives.
Absolutely. So the next time you sit in a chair or admire a table or even just navigate a public space, maybe take a moment.
Yeah.
Consider not just its comfort or its style, but the unseen layers of human ingenuity, the natural inspiration, the meticulous planning, the entire deep dive, you could say, that went into its very existence.